All right, for number one, 2019, this was a quiz, so please make sure you do this before you watch this video. It's talking about fish entering a lake. So fish enter a lake at a rate modeled by the function e, given there, e of t. Fish leave the lake at a rate modeled by the function L. Both E and L are measured in fish per hour, and T is measured in hours. So the first thing I know is that this is a classic rate in, rate out problem. E represents the rate at which fish enter, and L represents the rate at which fish leave the lake. So I'm going to take note of that. I'm going to write that down. I'm going to say E of T is my rate in, and L of T is my rate out. That's always a good practice when you're talking about rate in, rate out problems, so that you can understand what to do with those. And again, paying attention to the units, both of these have units of fish per hour. And so we can use those units to understand what we need to do. For example, if I'm asking for how many fish, we're going to be dealing with some sort of integral of these, because the integral of fish per hour is fish, and so on. So part A, it says how many fish enter the lake over the 5-hour period from midnight to 5 a.m. So we're looking for how many fish enter. Well, that is going to be dealing with the rate in, and because I'm asking for how many fish, I don't want the rate, I want the accumulation. So I'm going to be taking the integral of E of t. So that'd be the integral from 0 to 5 of E of t dt, and you're just going to plug that into your calculator. Hopefully, before we even started, you guys had E of t saved as y1 and L of t saved as y2 in your calculator. But as a result of this, we get 153.458. And then notice it says give your answer to the nearest whole number, because it doesn't make sense that half of a fish entered the lake in a pure context. So we would say that we have 153 fish entering the lake at that time, or by that time. So we would get 1 point for the correct integral expression, so 1 point for this statement right here, and then you're going to get 1 point for your rounded answer. For part B, it says, what is the average number of fish that leave the lake per hour over the 5-hour period from t equals 0 to t equals 5? Now, this is a little weird because it's combining a bunch of verbiage from a bunch of different concepts. So we have to be very careful about what it's actually asking for. Because here we see average number of fish. And if we stop there, we're thinking the average amount of the number of fish. But if we keep going, it says that leave the lake per hour. So we are actually asking for an average rate. We're asking for an average rate here. So we got to pay attention to those three terms there. It says, first of all, average, and then we're talking about leaving only, so that means we're going to be dealing with something about L of t, not E of t, and then per hour implies rate. Well, there's two averages. There's the average rate equation and the average value equation. And trying to understand what we're doing here, if I were to take the average rate of L, I would be getting the rate of the rate. So for the units of that, if I took the average rate, if I did L of 5 minus L of 0 over 5 minus 0, remember L is fish per hour, so the rate of that would be fish per hour per hour. I don't want that because I only want fish per hour. If I take the average value of this, well, the average value of this will be the units of L of t, so that would give me fish per hour, so that's what I want. So I'm going to take the average value of L. So we'd say 1 over 5 minus 0 times the integral from 0 to 5 of L of t dt. And again, let's understand the units here. L of t is fish per hour. When I take the integral of fish per hour, I'm getting fish, so the integral is fish. And then when I'm dividing it by this 5 minus 0, the units on that are hours. So we're getting 1 over hours times fish, which turns into fish per hour. And so that makes sense here. This is the average value of L of t, or it's the average value of the rate, because L is a rate, therefore it's the average rate in this case. So plugging that into my calculator, I end up with 6.059. The point values on this, you would get 1 point for having the correct integral. So if you use the integral from 0 to 5 of L of t dt, then you get that point, and then you would get 1 point for the final answer. For C, it says at what time t from 0 to 8 is the greatest number of fish in the lake. So here I'm looking for the maximum number of fish. So how do we find maximums? Well, we need to set the rate, the derivative, equal to 0 in order to find our critical points and all of that. But before we do that, let's define something here. I'm going to say let A of t, represent basically the amount of fish in the lake, but the best way to say that is represent the change in the amount of fish in the lake. Okay, so A represents the amount of fish, essentially. I can't spell amount, but oh well. But A represents the change in the amount of fish. So how many fish have been put into the lake, or the change in the amount of fish. Okay. Then to find so let me write that equation. That equation would be A of t equals the integral from 0 to t of e of x dx minus the integral from 0 to t of L of x dx. So the amount of fish, the change in the amount of fish, is equal to the amount that was added, because E represents the rate in, minus the amount that was taken away, because L represents the rate out. So the integral of the rate in is how many have gone in. The integral of the rate out is how many have gone out. So the amount in minus the amount out gives us the change in the amount, the overall change in the amount. So now to find the maximum number of fish, I need to take the derivative of the amount function. So when I take this derivative, it's going to say a prime of t, and then the derivative of the integral, this is the fundamental theorem of calculus, the derivative of the integral, remember, you're going to plug in the upper bound, so you get e of t, and then times the derivative of the upper bound, which is 1, minus, plug in the lower bound, so e of 0, times the derivative of 0, which is 0, so that all goes away, so you're left with just e of t here for the derivative. And then the derivative of this will follow the same rules, so we get L of t. So this is the overall rate of change. This is the rate. Remember, E represent the rate in, L represented the rate out, so the rate in minus rate out represents the overall rate. Now we're going to set our overall rate equal to 0 to find our critical points. Well, to do this, when I set it equal to 0, I notice that I can just add L of t to both sides. And what then I'm looking for is when the two rates equal each other. And so in my calculator, because I have this stored in my y-list as y1 and y2, I can just find the intersection of those two functions. Make sure you're looking at the correct interval from 0 to 8. When I find the intersections, I get t equals 6.204. There was only one intersection. So from here, my critical points are going to be when the rate equals 0, which is at 6.204. When the rate does not exist, well, the rate always exists according to what these functions are in the domain of these functions. And then at endpoints, so the endpoints are 0 and 8. So our critical points are 0, 6.204, and 8. Because I'm looking for the maximum, not a relative maximum, I'm looking for a maximum, I'm going to have to evaluate all of these critical points and figure out which value has the greatest amount of fish. So we're going to take each of these critical points and plug it into our amount function. And so the first one would be a of 0. So a of 0 is the integral from 0 to 0 of e of t minus L of t. And some of you might be saying, well, why did you put the integral of e minus L? Well, that's because the bounds on the amount function are the same. So it's from 0 to t and 0 to t. So therefore I can put the integrands together into one statement. If you kept it separate, that's fine too. But anyways, the integral from 0 to 0 is just 0. So the change in the amount of fish at t equals 0 is 0. Then I'm going to plug in 6.204, and using my calculator there, I end up with 135.015. And then the last one, I'm going to plug in 8, so we get the integral from 0 to 8 of e of t minus L of t, which is 80.920. So the question is, at what time is the greatest number of fish in the lake? So pay special attention to the question. It says, at what time? Well, we notice, at what time? We notice that the greatest number of fish in the lake is here. We can see that the greatest change is 135.015. And so we can say that the time when the greatest number of fish is in the lake is when t equals 6.204. As far as points go for this, you're going to get 1 point for setting E of t minus L of t equal to 0. So 1 point for getting to that line here. You're going to get 1 point for your answer. So basically all that work gets you that 1 point. And then also you're going to get 1 point for your justification. And again, your justification, when you're talking about absolute extrema, is going to basically be the work in finding all the values at your critical points. So 3 points for that problem. All right, part D, it says, is the rate of change in the number of fish in the lake increasing or decreasing? Now this one gets interesting. I'm not asking for is the amount of fish in the lake increasing or decreasing. I'm asking is the rate increasing or decreasing. So we are looking for whether the rate is increasing or decreasing, which means that we are looking for whether the derivative of the rate is positive or negative, right? Because remember, if a function is increasing, its derivative is positive. So if the rate is increasing, that means the derivative of the rate is positive. So what we're going to do is we're going to find the derivative of each of the rates. And remember, both of these functions, E of t and L of t, are rates. So we're going to take E prime of 5, okay, come on now, E prime of 5, plug that into my calculator, so the derivative of y1 at t equals 5 is negative 6.802. We're going to take the derivative of L at t equals 5 and get 3.921. And so what do we notice? We notice that the rate of the rate in is negative 6 and the rate of the rate out is 3.9. We can see that the rate of the rate out is greater than the rate of the rate in, and therefore it is decreasing. And we'd say since L prime of 5 is, and that's wrong, L prime of 5 is greater than, let me fix that real fast, L prime of 5 is greater than, oops, E prime of 5. Okay, so hopefully that made sense to you. It's the rate of the rate. We're asking for whether the rate is increasing or decreasing. So now let me just take a step back. If it were asking, is the amount of fish increasing or decreasing, then we would need to be taking the derivative of the amount and then seeing whether the rate in is greater than the rate out. So in that case, we would just be plugging in 5 to E and L. But because we're asking whether the rate is increasing, we need to take the derivative of each of the rates. Anyways, you're going to get 1 point for considering E prime of 5 and L prime of 5. So knowing that you had to take the derivative of each of those at 5. And you're going to get 1 point for your answer with your justification. So here my justification was because L prime of 5 is greater than E prime of 5. Somebody might say because, another way of saying this is because E prime of 5 minus L prime of 5 is less than 0. And that would be perfectly fine as well. So that wraps up this question. Make sure you grade it and input the last two questions, the scores that you got on the last two questions into Socrative. And then for the next question that you're going to do, you're going to set your timer for 10 minutes and you're going to do number 2 of 2017. This is a calculator-based question. And when you're done, come back and watch the next video, and I will see you then.